To discuss the mission Mausam that was launched by the Prime Minister today, I am joined in the studio by Dr. Mrityunjay Mahapatra. He is the Director General of the Indian Meteorological Department. Welcome, Dr. Mahapatra, to the show. First of all, in very layman terms, what is mission Mausam? What does it do? And how will it help in weather forecasting?
Mission Mausam is a very ambitious mission as launched today by Honorable Prime Minister. As all of us know, we have come a long way over the past decade, especially in terms of improvement in weather forecast accuracy. Almost 40 to 50% improvement in forecast accuracy has been possible in the recent decade compared to previous decade. As a result, the number of deaths due to the several disasters like the cyclones, heat waves, cold waves, heavy rainfall has decreased significantly, and also the loss of property to some extent.
No, but Dr. Mahapatra, this is what mission Mausam will do. If I do not understand what you do at the IMD, apart from understanding that you give us weather forecast, tell us whether it's going to rain tomorrow or not. What is mission Mausam? Are you going to deploy technologies? What is it?
Yeah, mission Mausam is a mission where the objective is to improve the forecast further, so that at present whatever is the level of accuracy, that should improve by 10 to 15% by next 5 years.
How do you do that?
To do that, the process by which forecast is provided by India Meteorological Department will be improved in each and every component. Weather forecasting is an initial value problem. That means, if we can detect the initial status of ocean, atmosphere and land surface processes, then we can predict the weather better.
Okay.
And detection is possible only if we have a very dense observational network.
Right.
At present, we have got 39 Doppler weather radar, which is covering about 85% of the area of the country. Total area is not covered. Under mission Mausam, number of Doppler weather radar will be increased to 126 during next 2 to 3 years.
And will that cover all area of the country?
That will cover all India. All India will be under radar coverage.
So right now, the predictions that you give are just about 85% of the country.
Now,
right?
it is based on the radar coverage of 85% of the country.
Okay. 15% of the country, you do not know what the weather patterns are going to be like.
Based on radar.
As of date.
Yeah. Why I am talking of radar? Because radar is such a powerful tool where every 350 meters, whatever is the severe weather occurring, that you can detect.
Okay.
So therefore, if we increase the number of radar, whatever small scale localized severe weather event is occurring, that will be detected. No severe weather, whether it is thunderstorm or lightning or the heavy rainfall, will not go undetected.
Okay. So
and
one under
accordingly,
mission Mausam, you are going to increase the number of weather detecting radars to 126.
Yes.
And that will give us a pan-India coverage.
Yes.
Right?
And that will also help in improving the weather forecast of those severe weather events.
All right. What else under mission Mausam is IMD going to do?
Yeah. The next target is that at present we understand the atmosphere by releasing the balloon along with the sensors only twice a day over 56 stations, which is not adequate to understand completely the three-dimensional structure of the atmosphere. The proposal is that this number of stations, which is 56 now, will be added with another 60 number of stations across the country, so that more dense observation of the vertically temperature, wind and humidity distribution will be carried out. This temperature, wind and humidity are the three vital parameters for improving the weather forecast. Once you get that, certainly the weather forecast will improve. Okay. The next one is that we will put off the wind profilers. At present, once you take observation in the morning, another observation you take in the evening. You have got two observations only. But during the day, there could be a number of changes in the atmosphere. that is not being monitored and we do not know. If we can put wind profiler, which can take observations up to 10 to 15 kilometers every minute, you will have observations. Then if you can have radiometer, that will give the observations of temperature and humidity also every minute. So by that way, continuous monitoring of temperature, wind and humidity will be carried out in the atmosphere. That
you will give
help
the
us.
predictions real time.
Yes.
But you saying that right now you mount your sensors on balloons over 56 stations, and that is done twice
in a day.
But why can't you flutter the balloons all the time, and why can't they give us real time data from at least these 56 centers as if now?
Yeah, you need technology, number one, for that. And also you need investment for that. Each balloon along with the sensors, once it is released, that cannot be reused. It is lost.
Okay.
And cost is around 15 to 20,000. So therefore, you need investment. And Government of India has invested now to increase those number of stations, and these balloons will be followed by the GPS. And therefore, it is very accurate observations, and these accurate observations improve the forecast of our models.
How do the other countries who are advanced in the weather forecasting do it? Do they give out real-time data?
Yeah, when we take off this mission Mausam to our hand, before that we went for a benchmarking to find out the leading countries, what is their status with respect to weather observations. Now, we were far behind in terms of the Doppler weather radar. With the number increasing to 126, we will be at par and even better than many leading countries of the world. Similarly, with the number of stations with balloon and sensors releasing facility increasing to 56 now plus 60, we will also be at par and better than them. Another point is that India is a tropical country. The variation in India is more than the countries like Europe or USA, etc., which are the extratropical countries. Their variation is quite less. Their weather systems are very orderly.
If as a layman I can understand, why are the variations more in a tropical country?
Because in tropical country, heating is more. The process is called as convective process. There is a convection of the air particles associated to the humidity, that is water vapor, in the atmosphere. But there it is not the convection because temperature is less there. So therefore, convective process is not there. In tropical area, because of the sun's heating, the convection process is more, and this convection process gives rise to localized development of the clouds, which can cause thunderstorms or which can cause heavy rainfall, without even any weather systems like depressions or cyclones or low pressure systems. So therefore, the uncertainty in predicting the small scale localized weather events becomes more in tropical area compared to the mid latitude or the polar regions area.
Okay.
So therefore, it is becoming more essential to have more dense network, accurate network, and more frequent observations to network to monitor such small scale localized events and also to predict such localized events. Another reason is that the climate change. Because of the climate change, the frequency of small scale localized heavy rainfall events are increasing. So if you want to detect them, it is localized means its size is quite small. Also, if a particular part of the city is getting heavy rain, other part may not get heavy rain. In such situation, in a city, you cannot afford to have only one or two observations. You should have a dense observation, say every 4 kilometer, 3 kilometer observations. And you should have a model which can run at a resolution of 1 kilometer. That means every 1 kilometer forecast can be generated. Then only you can detect that type of small scale localized heavy rainfall events. So that is the objective why we are taking off mission Mausam, where the observation network will be multiplied to catch up each and every small scale localized heavy weather events, heavy rainfall events or thunderstorms or lightning. And once you detect, these data will be utilized in our models with the augmented high performance computing systems, and forecast will be generated in the localized scale with higher accuracy.
Is there a timeline, Dr. Mahapatra, to that?
Yeah, this is 2 years timeline. Mission Mausam, whatever has been taken off now, it has to be implemented in 2 years. So therefore, I am sure within next 2 years, you will find a transitional change, a specific change leading to almost 100% detection of these thunderstorms, lightning, localized heavy rainfall, and also 10 to 15% improvement at least in their prediction in short range up to 3
You
days.
have all the funding and the talent and the resource, human resources to finish this in 2 years?
Yeah, we have the funding now. Government of India has released the fund, around rupees 2,000 crore has been sanctioned, and already we are in the process in the procurement of the radars, wind profilers, microradiometers, etc. The high performance computing system of Arca and Arunica already has been procured in September. Honorable Prime Minister has inaugurated it. And another high performance computing system also in the process of procurement by IMD. Then we also need the people. We are in the process of augmenting our manpower in India Meteorological Department and the concerned agencies.
So we'll see a massive recruitment drive by the IMD in concerned departments where you require them.
Yeah, in the Ministry of Earth Sciences.
All right, we leave it there. We hope we have more accurate weather forecast. Congratulations on the 150th anniversary of the IMD. Thank you very much, Dr. Mrityunjay Mahapatra, for joining us on this.
Thank you very much.